This video is about naming acids, and acids are going to behave kind of like ionic compounds. When you put them in water, they will dissociate, and you are going to get cations, which in this case with acids, the cations for us is always going to be hydrogen with a +1 charge, and then you're going to get anions formed also, and the anions can either be single elements, which means you'll have binary acids, or they could be polyatomic ions. So we're going to use the polyatomic ion sheet for some of these also. So examples of binary acids. You can have HCl, which is hydrochloric acid, or HF, hydrofluoric. You can have H2S, which would be hydrosulfuric acid. There's a couple examples you could do here. And when you're naming binary acids, they always get the prefix hydro. So you're going to use the prefix hydro, so it's like hydrochloric or hydrofluoric or hydrosulfuric. You're going to have the root of whatever that anion is. So the chlorine, the fluorine, the sulfur, the thing that has the negative charge. It's always going to be changed to end in IC, and it will obviously always have the word acid in there. All right, so binary acids, you use hydro, change the ending of the anion to IC, and then you throw acid in at the end, throw that name in there. Now there's also ternary acids, and ternary acids can also be called oxyacids because they're going to have polyatomic ions in them, and most polyatomic ions have oxygen in them, so they kind of get called either one, ternary or oxy. And what happens here is you have to look at the polyatomic ion. So if you don't have your polyatomic ion sheet out, get that out. Now for these, and there's a lot of different examples, you can have H3PO4 as an example, or HNO3, or H2SO4. These have hydrogen, because our acids for us are always going to have hydrogen in them, and you're going to have a polyatomic ion. So what happens is if the polyatomic ion ends in ATE, what you do is you take the root of that polyatomic ion and you change the ending to IC and put the word acid at the end. Notice for binary it has hydro as a prefix. For ternary we do not have hydro in there. So there's hydrochloric acid, and then you can have chloric acid. Hydrochloric is the binary one. Chloric acid would have the chlorate polyatomic ion in there. Now the other polyatomic ion ending is ITE for these, and they go to OUS. So you can have phosphorus acid, that would be H3PO3, because PO3 is phosphite. One of the ways people remember this, and it sounds kind of silly, but if it helps, go for it, is I ate something icky. So 8 being the polyatomic ion ending, so if I ate something icky, 8 goes to IC. Okay, we can go over some examples of these, and I'll just come up with random examples. Alright, so if you have H2S, you can have also H2SO4, and you can have another acid that's H2SO3. The first one, H2S, is binary. So what's going to happen is that we'll get the prefix hydro. Sulfur goes to sulfuric. So it's hydrosulfuric acid. H2SO4. Well, now SO4 is a polyatomic ion. So we're not going to have the prefix hydro in there. And SO4 is named sulfate. Now this is an odd one. They actually put the UR back in there, so it becomes sulfuric acid. It's not sulfic acid, and I think they did that just to make it a little more consistent and just make it sound a little better. Since you have hydrosulfuric, we now have sulfuric acid. All right, H2SO3, another polyatomic ion, so we do not have hydro in the name. SO3 is sulfite, so this becomes sulfurous. Again, they put the UR back in there because you're going from things like sulfate and sulfite, where they drop the UR to get these names. Well, now they're putting it back in for the acid, so you get sulfurous acid. And the way we get these subscripts, these 2's, if you were working backwards, acids for us are always going to begin with +1. So as soon as you see the word acid in there, write H +1. And sulfur off the periodic table is S-2. So we crisscross the oxidation numbers just like we did with ionic compounds. Because remember I said acids will behave like ionic compounds. When you put them in water, they will dissociate and you will get cations and anions. So when you know that, once you know that you're going to get cations and anions, you have to think about the charges. So for sulfuric acid, once you see acid, write down hydrogen with a +1. Since it ends in IC, it's telling you you're going to have to go to sulfate, which is SO4 with a -2. And remember, since hydro is not written in front of this, that's telling you you have to go to a polyatomic ion. So once you realize there's no hydro, you look at your polyatomic ion sheet and you look at the ending here. IC goes to 8, so I ate something icky. OUS will go to the polyatomic ion that ends in ITE. So if you have hydrogen that's +1, SO4 that's a -2, you crisscross the oxidation numbers just like we did with ionic compounds and you get H2SO4. And we can do this one for sulfurous acid. Crisscross the oxidation numbers and you get H2SO3. The good thing with acids, when we work with them, they always begin with hydrogen. So you're always starting off with something that is H with a +1 charge. So let's say, and I'll just come up with random examples. Let's say we're going to talk about carbonic acid. Well, hydro is not written here, so you know you're going to need a polyatomic ion. But as soon as you see the word acid, start off with H that's +1. And now there's no hydro, so we look at the polyatomic ion sheet, and what you get is carbonate. Let me just clean this up a little bit. Since this ends in IC, you end up going to the polyatomic ion that ends in ATE, which is carbonate, CO3 with a -2 charge. You crisscross the oxidation numbers and you get H2CO3. Hydrochloric acid, let's say we worked with that name. A very common acid. You have hydro first, and you see that it says acid, so we know it's beginning with H. That's a +1 charge, and since hydro is there, it's telling you that it is binary. So you do not need the polyatomic ion sheet. You just look at the root of this word, which is chlorine, and you crisscross the numbers and you get HCl. Now compare that to chloric acid. Well, again, we have acid in there, so we're going to begin with hydrogen. That's a +1 charge. Now hydro, the prefix hydro is not in there. So that means we have to look at the polyatomic ion. So we want to look at chlorate. Since this ends in IC, I ate something icky, you go to the polyatomic ion that ends in ATE. You get chlorate is ClO3 with a -1, so you just put these together. The ones cancel out. If we wanted to do, say, nitrous acid, hydro is not present. It says acid. We know we're starting with +1. We know we have to look at a polyatomic ion, and since this ends in OUS, you look for nitrite, which is NO2 with a -1, and you put these together, HNO2. Now, one of the things about acids is you're never going to have to put parentheses around a polyatomic ion because you always start off with hydrogen. That's a +1 charge, so you don't need the parentheses. So I'll just rewrite it as HNO2. But that is a general idea. Binary gets the prefix hydro. It always ends in IC. Ternary or oxy acids do not use hydro, and you have to look at the ending of the polyatomic ion. Polyatomic ions that end in ATE change the ending to IC, so like phosphoric acid. And polyatomic ions that end in ITE, like say you were working with phosphite, that would be phosphorus acid. And like I said, every once in a while they put some